A typical first step in analyzing your data is getting to know your data in the first place. For Numpy arrays from before, this is pretty easy, because it isn't a lot of data. However, as a data scientist, you'll be crunching thousands, if not millions or billions of numbers. Imagine you conduct a citywide survey where you ask 5,000 adults about their height and weight. You end up with something like this. A 2D Numpy array, which I named NP City, that has 5,000 rows, corresponding to the 5,000 people, and 2 columns, corresponding to the height and the weight. Simply staring at these numbers like a zombie won't give you any insights. What you can do, though, is generating summarizing statistics about your data. Aside from an efficient data structure for number crunching, it happens that Numpy is also good at doing these kinds of things. For starters, you can try to find out the average height of these 5,000 people with Numpy's mean function. Because it's a function from the Numpy package, don't forget to start with np. Of course, I first had to do a subsetting operation to get the height column from the 2D array. It appears that on average, people are 1.75 meters tall. What about the median height? This is the height of the middle person if you sort all persons from small to tall. Instead of writing complicated Python code to figure this out, you can simply use Numpy's median function. You can do similar things for the weight column in NP City. Often, the summarizing statistics will provide you with a sanity check of your data. If you end up with an average weight of 2,000 kilograms, your measurements are most likely incorrect. Apart from mean and median, there's also other functions, like core_coef to check if, for example, height and weight are correlated, and std for standard deviation. Numpy also features more basic functions, such as sum and sort, which also exist in the basic Python distribution. However, the big difference here is speed. Because Numpy enforces a single data type in an array, it can drastically speed up the calculations. Just a side note here. If you're wondering how I came up with the data in this video, I simulated it with Numpy functions. I sampled 2 random distributions 5,000 times to create a height and weight race, and then used column stack to paste them together as 2 columns. Another thing that Numpy can do. Another great tool to get some sense of your data is to visualize it, but that's something for later. First, head over to the exercises to learn how to explore your Numpy arrays.